All right, so let's see how you did on this one. So Pearl's starting a lawnmower business. She has $1,200, so that's your starting number, and plans on spending. So hopefully you didn't add 45. We're spending $45 each week on advertising. So she started with 1,200, and now she's losing or spending $45 each week. So this is going to look very much like the one on the other side. Let's run through it quick. So after week 0, she still has 1,200 because that's what she started with. Week 0 would be your starting point. Now she's going to subtract 45 every single week. So I'm going to subtract 45 here, and that's going to leave me with 1,155. Subtract another 45. Since this is just counting up week 1, week 2, week 3, if this all of a sudden went to week 73, you couldn't just subtract 45. You'd have to do some calculations. But since we're just going week by week by week, you can do this. Take 45 off of it, 1,110. And then one more time, you should have had 1,065. So the calculation was you started with 1,200 and you just took off 45. After 2 weeks, you started with 1,200. You took off 45 week 1 and you took off 45 week 2, leaving you with this. And in 3 weeks, you had 1,200 and you minus 45 for week 1, week 2, week 3. So there's your calculations. Now the pattern is going to simplify this. So it's always 1,200. It's important to recognize what is showing up every single time. It's always minus in our calculations, and it's always a certain number of 45s, and that number is based on the number of weeks. So here we had 145, and here we had 2. So instead of subtracting 45 twice, you can do 45 times 2 and get 90. Just take 90 off of it. And this is 45 times 3. Okay, so if I was going to come up with a pattern, it's always 1,200 minus 45 times the number that changes is your variable, and it just represents the weeks. So W. Going back to the original, 1,200 minus 45 0 times still gets me 1,200. My starting calculation was just 1,200. So this is what yours should have looked like. Pause the video, make some adjustments if needed. All right, example number 3, we're going to talk about instances. So here's a pattern, x plus x equals 2x. Okay, we want to prove that this is true. If you look at it, if I simplified this side, I get 2x. So of course, 2x equals 2x. So we want to give 2 instances that prove this pattern actually works. Okay, so we're going to have a first pattern and a second pattern. And each one is a different instance. So when I say instance, it's literally just a different time something else happened if these x's represented a situation. So it could be, if let's say we're just weeks again, so number of weeks. So depending on every situation, the number of weeks is different. So we're just going to plug in 2 numbers to this pattern and see if it works. So pick easy numbers. So my first instance is going to be for x equals 1, and my second instance is going to be for x equals 3. Pick easy numbers. So I'm going to plug them in. So start off with your original pattern. Plug in your instance or your value for x. So x becomes 1. This x becomes 1. This x becomes 1. Remember when the number is attached, that's multiplication. Simplify both sides. 1 plus 1 is 2. 2 times 1 is 2. It's kind of like running a check back from middle school. You want to make sure that both sides come out equal, and that proves the pattern works. Now, just because it works for one instance doesn't mean it always is going to work. So we want to try something else. So let's plug in another number. Let's plug in 3. So 3 plus 3 is the same as 2 times 3. So I get 6 and 6, and I'm good. So there's 2 instances. So go ahead, pause the video, see if you can come up with 2 instances on this side, and then play the video back and make sure yours makes sense. So for my first instance, I'm going to pick something nice and easy. X equals 1. So starting with 3 times the quantity, x plus 2 equals is the same as 3x plus 6. If you notice what this is, that's the distributive property. That tells you you're allowed to multiply 3 times the x and 3 times the 2 and get these 2 terms, and they're going to be equal to each other, that it works. So we're proving that this distributive property works. So let's plug in our number. 3 times, plugging in 1 for x. 3 times 1 plus 6. Simplify both sides one step at a time. So inside parentheses, 1 plus 2 is 3. Over here, 3 times 1 is 3. And now 3 times 3 is 9. And 3 plus 6 is 9. Okay, so it worked. My second one, I'm going to pick another easy number. How about 0? Again, yours didn't have to be the same. You get to pick whatever you want. It just says give 2 instances, so you choose. So starting with my original, yes, you should write your original. And now substitute. So x becomes 0. X becomes 0. One step at a time. So this becomes 3 times 0 plus 2 is 2. 3 times 0 is 0. So 3 times 2 is 6. 0 plus 6 is 6. So it works. Distributive property will always work. Okay, so when you look in your homework tonight and they ask you for 2 instances, it's just come up with 2 numbers, plug them in, prove that they work. That's an instance. All right, last but not least, we've talked about this all the way back to 7th grade, how many terms there are in an expression. So a term, if you go back to your definitions real quick, is a number or expressions that are added. It could also be a factor. So let's look at this. So when I look at this very first one, and I asked you how many terms there are, people will usually either say 2 or they will say 4. Okay, they'll either just say, well, here's 1 and here's 1, so that's 2, or they say the number, the letter, the number, the letter, that's 4. So the correct answer here is 2. There's 2 terms, and that's there. And these, oops, this is a product. So terms can be a variable, it can be a number, or it could be a product. So 2a is a product. Okay, it's being multiplied, but that's really going to represent one number. And 3 times b is a product. So when I come over here, this is a number, this is a product, and this is a product, and they're all being added together. So here there are 3 terms. And right here, people would also say 3 terms, but really terms are separated by addition and subtraction. And if you look here, there's no addition or subtraction. This is just one product. This is all being multiplied, represents one number. This is one term. Coming over here, again, look for your addition and subtraction. It's going to separate your terms. This is an expression, 1 term, 2 terms. And over here, this is just 1 term. So as we start looking further and further at expressions, there's going to be different numbers of terms, and you just need to know what that vocabulary word basically means.